Hey, in this episode we're going to build the floor system for the main house. Let's get into it.
Hey, so it's the middle of January, the weather is incredible, we have a nice little heat wave. I'm actually working by myself because Marcela, can you guess where she is? Yeah, that's right, she's in Mexico, so anyway, I'm trying to get some things done that I can do on my own. So for example, we have basically set up all the sill plates for the entire house actually. And now I'm setting up the last one. So this is the last chance to tell you about this. Typically the sill plate has a foam gasket, but those are not that great anyway because they actually end up turning into like paper with the weight and all that stuff. I wouldn't recommend those. We found these conservation technology gaskets. They are basically like a gasket that you put onto a chamber or something. With the pressure and all, it will fill all the gaps. This is rubberized, so basically it will not harden over time. So this will be our advanced way of doing the air tightness, water tightness, and bug tightness. This is a little bit pricier, but it is highly recommended. We're not sponsored in any way or form. So what you do is basically you cut it to size, and then you staple it maybe every 8 inches, 12 inches. And once you're ready to go, you install it. Finally, we're using this Dynaflex 230. It's a DAP product. You gotta be careful because some materials don't play well with rubber. Some materials might dissolve rubber, so in this case we looked around, we read the instructions and it says it plays well with rubber. So what I'm going to do is I'm going to apply a bead of Dynaflex through the entire foundation where the sill plate goes. Then the sill gasket will come in, push it in, and then it'll be like a bulletproof approach basically. As the sill gasket covers some of the holes, this will take care of covering the acoustic sealant microscopic hole. So yeah, this is the last sill plate of the entire house, so it's quite exciting. We're starting to move up, so let's get it done. Alright, so before we begin continuing on the floor system, the very first thing to do is to pack this metal. The problem with packing it right away is the fact that I don't have the layout. So what I'm going to do right now is I'm going to set the layout for the walls, the joists that will come across like little ribs. And I'm going to mark also the layout along the metal. That's very important because since it's getting packed and ram set and all that stuff, I don't want any of those nails to interfere with the connectors themselves. So it's important to know where they are before they get assembled. Another thing I wanted to mention is, isn't it kind of like, I don't know, tricky when you think about it, how to start your layout? Like you begin like at 15.25, and then every one after that is like 16 inches on center. So let's go down and then I can explain you how that actually works. Okay, I'm going to try to explain something super basic that I'm sure a lot of you already know, but for the people that are brand new, this hopefully will be beneficial. So that is how to do layout. The thoughtless rule of thumb for a 16-inch on center layout is you begin your layout at 15.25, and then every stud after that goes 16 inches. Basically, you grab one edge of your stud, the leading edge, and then you move forward. So where did that 15.25 come from? So basically, 2 by nominal size is actually 1.5 inches. And so 1.5 inches divided by 2 is 3/4. Your layout is 16, so 16 minus 3/4 is 15.25. And so that will guarantee that the last 8 foot for your sheet good will be perfectly centered. And that will allow you to nail properly. If you were to start like at 16, you would either end up perfectly flush your sheet good on one side or on the other. So that means your sheet wood would only be able to nail on one side or the other. What I mentioned actually applies for any kind of layout, but if you ever get confused, my suggestion is if you can go to the 8 foot layout, mark it perfectly at 8 foot, And you know that that mark is the center of the stud that goes on that side. So from there you can mark your layout on one side and then start working yourself backwards and then forwards from there. Not to throw shade on any particular product, but look, our wall was protected by Tyvek, one little windstorm and it's gone. So either we have to do it again or we do what I'm going to do now, which is going to be put zip panels to protect it. We don't want those cavities to be filled with the snow, so yeah, I'm going to move that Tyvek over here to protect this material. It has a nice waxy cover, so when it snows I should be able to just sweep it off.
So we have this part of the floor system already done, but we're getting away from solid ground and we have some heavy LVLs that we need to install. So our goal is to do the blocking in here so we can walk in, put our subfloor, and continue our work.
So today I'm installing the packing on the other side of the steel. I've already done this side. Let me show you how we're actually doing it. So as you can see, there's a top plate and then there's the packing. We want this packing to be as flush as possible. This way the connectors for the joists, they have a nice flush area to sit against. And then the top plate is basically where the joists get connected to. One more thing is the ram set. We were having difficulty initially by installing it this way, and as you can see, they're not all the way through. They are going into the metal, no problem. It's just that the heads are staying out. And so we've improved on that technique, so let me show you how we're doing that. Okay, as I mentioned, we were having difficulty getting the ram sets to go in. So one of the things I've started doing is I've drilled a hole through the LVL, the perfect diameter of the ram set nail, and then I've also drilled a countersink hole for the head and washer to rest in. By doing this, we guarantee that there's very, very little friction of the nail going through this particular LVL, and it has more force when it goes into the metal. If we add to that, once it crosses the metal, it still has to go a little ways through a small section of LVL, so the more force it has to go through, the better. Okay, I was talking about getting this packing as flush as possible, but as you can see, this flange on this metal is actually wider, so we're going to have to add another piece of subfloor so that we can get this as flush as possible to the flanges. One final comment on ram setting is, did you know that ram sets are basically powder actuated nail guns of sorts? So they're basically like a gun. They have a big kick, so my suggestion is to hold them with your shoulder if possible. Take care of your wrist, because from experience I can say that nailing all these ram sets, at the end of the day your wrists are going to hurt, so just be aware of that. So with that said, let's get to do some ram setting. Our steel contractor did not properly level this particular beam. This beam is actually low, like 3/4 of an inch with respect to the rest of the foundation. The beam back there is actually acceptably okay. It's 3/8 of an inch lower. So because of that height difference, we're adding a small piece of subfloor so that we can catch up to the proper level and be as level as possible. we're about to install our final beam support for this particular project, and I'm going to show you how we do it. One of the main reasons we do it is, so typically we will use like Simpson connectors and whatnot, but in this particular case, in some situations, we run into problems because over there you see we have some metal, and that makes our life very difficult to install it using a Simpson connector, so we use beam supports. So let me show you how we assemble these posts. So we begin by sistering a couple 2x4s, pressure treated. They're pressure treated because they're next to concrete, so that makes them resistant to moisture from the concrete. Next, the specifications from the engineer call for 16-inch on center, making the posts as long as possible. As you can see here, we have one installed, but not touching the slab because the slab is a rough slab and it's supposed to be disjointed from the main structure. Finally, as you can see here, I begin my first hole at about 3 inches, and the reason I do that is so that I can avoid splitting on the wood. Finally, let's talk about the Simpson Titan HD bolts. These are 8-inch long and 5/8 wide, and as you can see, they have threads. They are kind of self-tapping threads. So basically, Simpson recommends to use a 5/8 drill bit so that as the bolt goes in, they basically carve their own hole. Also, Simpson, let's talk about Simpson recommendations. So basically, Simpson recommends to use the same drill bit, but also to drill the hole half an inch longer. At this point in time, they give you the choice of dusting out the hole or drilling it longer. In our case, we just do both because it's just easier. Finally, in a previous episode, we had used a drill, our regular, it's a nice drill, but not nearly as good as a hammer drill. And this is a recommendation from one of our viewers, Jorge. He recommended we use an SDS hammer drill, and it makes our life way, way easier. With this guy, I can drill the hole basically in like 5 minutes at most. With the previous drill we used, it took me like 2 hours to drill one single hole. So thank you, Jorge.
So we have been busy at work and we have made good progress. As you can see, we're about 2/3 of the way there. We have been installing joists and LVLs and blocking, and we got our first sort of rookie mistake. If you can see this blocking here, well, if you see this LVL, it has sort of a belly. And what happens is that this blocking, it was pretty tight, and we said, yeah, we can hammer it in. And we hammered it in, but now we have this problem. And what happened here is that when we measured this blocking, the size was right, but as we installed the other blockings, like this one kind of pushed this joist a little bit this way, and that's what made this one really tight. So now we have to fix it. Let's talk about Simpson connectors. These are usually specified by your structural engineer, and you can find the Simpson model right here at the bottom of the connector. So they have different types of holes. You can see these round ones here and here. These are always required. Whenever you see the round one is required, all the other ones can be either optional or required if your engineer specifies them. So that's why you see the different shapes like triangles and diamonds and ovals and whatnot. Now, the size of the nail is pretty important because if you change the size of the nail, you're going to affect the shear value. So be very careful with that. Now, when it comes to installation, Simpson allows 3 different methods for installing the nails. So one is hammering, the other one is with a nail gun, but it must have a hole finder. So what that means is that I can put the nail exactly where the hole needs to, in the hole exactly as it needs to be. And the other option is the palm nailer. And honestly, we don't see this very often at the construction videos, but these ones are awesome. It's definitely worth a try, and they are not even that expensive. So once we have the connector in place with all the nails, what we do is we apply a bit of our favorite construction adhesive just here, and then we install the beam, and that's going to help prevent any squeaking for the floors. So we're about to finish the first part of the floor system, but we realized that we're missing one piece of lumber, so we had to do an emergency run. But check out our amazing construction truck.
18 Fahrenheit, windy, March 25th. What happened to spring? The name of this episode has been Shoveling Snow, but we're finally done with this part of the floor system. There's a lot of little details that go on, from like steel packing, blocking, and all that stuff. So now let's just install that 108 subfloor. So after 2 or 3 months of work, we are finally done. It's crazy. This episode should be named like Shoveling Snow, because that's basically our life. As you can see, we still have some snow, but it's finally starting to warm up. And so check this out. We have the subfloor installed, at least the first half. The next episode will be when we install the cantilever. That should be probably a pretty quick episode. But check this out also. It's super awesome. We have some help finally. So hopefully we'll start moving significantly faster and take care of this house before next winter, which is probably in like 6 to 7 months. So awesome. Let's go downstairs and let me finish up with some final details, and we'll just close it out. So we are downstairs. As you can see, there's now shadow. It looks amazing. We finally have installed all the subfloor. I will show you how we install subfloor in the next episode. This way we don't extend this too crazily long. As you know, it's been long enough. But I wanted to show you one very important detail, and I want to share this with you. I know it wasn't required by the engineer, but adding blocking makes a tremendous difference. As you can see here, this blocking makes the floor super stiff. Not only does it make it better for the house overall, but it also allows you to build much easier. Because if you've ever done joist building, you will know that they just wiggle and dance all over the place. So this is, let's say, the pro tip of this episode. I know it costs a little bit more money, but I think it's worth it. And with that, let's just close it up. And thank you for watching. Please consider liking and subscribing. It really helps us out. And we'll see you in the next episode when we do the cantilever.